Hello, and welcome to the instruction on inequalities, where we take something that used to look like 3x plus 4 equals 11 and change it and say, okay, what if it's 3x plus 4 is greater than 11? Well, what did we do here? Well, we subtracted 4, so we get 3x equals 7, and divided by 3, we get x equals 7 thirds. Over here, same exact process, and so that's going to be the first thing. We have the same process. All of the power that we experienced in solving equations, we're going to use over here. Subtract 4, we get 3x is greater than 7, and then x is greater than 7 thirds. All right, so this has exactly one answer. This one has a billion answers. You could have x equals 12 or 19 or 38.6, any number that is bigger than 7 thirds. So we run into a little bit of an issue. We can't write them all down, and so we graph them. That's why we graph them, is because we can't write them all down. We put a little thing here. You will not need a particularly detailed graph. Say, tell me where 0 is and tell me where the important number is, 7 thirds. Now notice that when we are coloring this in, x is greater than or equal to 7 thirds, we're coloring in all of these numbers up here. And how close do we get down here? Well, you can't really tell, but we don't want 7 thirds because 7 thirds is not one of the answers. So we put an open circle there. That says 7 thirds is not part of it. So here, the official way of writing this is the set of all x's such that they meet this criteria, and this blue stuff around here just makes it look really nice for the math guys. That's good. So that's called set notation. And that's, yeah, the set of all x's such that they meet that criteria. Those are the solutions. This is a graph. And you'll notice that if we put this one together with this one, in other words, put a little equal sign here, we actually have two problems that are going on that we can now say, hey, 7 thirds is indeed one of our answers. So that would fill in this dot here. All right, so let's go through that. There's another way of graphing these with different symbols, and it would be that if it's an open circle, that's the same as having a parenthesis right here, pointing the direction that you're going. And if it's equal to complete circle, it would be one that looks like this. It is a bracket pointing the way that you go. This allows for one more way of writing an answer, and it is called interval notation. You'll notice the answer here is we are taking the interval from 7 thirds up to infinity. So this open, or when we did it with the open circle, would look like this: 7 thirds up to infinity. There's that symbol there, and say it starts with that same symbol that means open circle. And of course you can never quite hit infinity. So interval notation looking like the red one, when I put this equal sign up here where it includes 7 thirds, would look like this. I don't think it will be necessary on the answers in your homework, particularly in this class, that you write it in interval notation, but when you hit college algebra, pre-calculus, they will often have interval notation. So this is just a way of taking the graph and putting it into something that you can type. Let's try a problem over here. Okay, here we have one. Negative 2x plus 4 is bigger than 12. We do the exact same process as what we did before. Subtract 4, you get negative 2x is bigger than 8, and then we divide by a negative 2. Now we have to stop right now because this is where the inequalities have an unusual thing happen to them. We notice that when we go back and do something simple like 5 is bigger than 2, if we add something to both sides, like 3, we get 8 is bigger than 5. Yeah, if we times by 3, we get 24 is bigger than 15. Now notice what happens if we make both of these negative. So a negative 24 and a negative 15. What happens there? Which one is actually bigger? And you're right, this goes the other way. We need to see that on a number line. Yeah, if you have 0 right here, here's 15 and here's 24, when you flip them over negative, what used to be bigger is now smaller. Let's label these 15 and 24. The negative 24 is now smaller. In real world talk. If somebody had $15 and $24, this guy's richer. But if you turn their money to debt, made them both negative, it actually switches the direction, which is what negatives do. This guy that's only in debt $15 is now the richer one. So if you ever multiply or divide by a negative number, you must switch the sign. Let's write that up here. Except for multiplication or division by a negative, not to a negative number. Then you switch direction. That's crucial. Switch direction. So on this guy right here, this is a -4, but you'll notice that this guy switched direction. So the graph, let's put this graph on here. There is 0 and -4. We are going to be less than -4, so it will go this way. Okay, the new symbol we have here is a parenthesis with an open circle because we don't include 4. So this is set notation. This is a graph, and the interval notation, we would go all the way up from -infinity to -4 and not quite hit it. So this is set, this is a graph, and I think your instructions in your textbook may only have you graph it, or may just have you write that answer there, or interval notation. Great, that should summarize what you're going to do with inequalities. To the boards! Okay, here you go. At the boards, 4 problems. Solve these, graph them, and then write the answer in interval notation. Go ahead and pause the video, and after you've had a chance to work them through, unpause. And welcome back. So let's do it. Solve this. We're going to solve it exactly like what happened with equations. So 4x minus 3 is less than 11. Add 3 to both sides. We get 4x less than, adding 3 over here, we get 14. Divide both sides by 4 and we get x is less than 14 fourths. And 14 fourths reduces down to 7 halves. So x is smaller than 7 halves. So the graph would look like this. Let's do a number line. There's 0. 7 halves would be somewhere up here, about 3.5. So you can just mark where that number is. And then, let me see. So that is the graph, and it is less than. So you would use an open circle and go this way. Less than. Remember, we're on the smaller side. Or preparing for interval notation, a parenthesis right there, and going that way. So here's solving it. Here's the graph, and then interval notation would mean all the way from -infinity all the way up to positive 7 halves, and we use that same symbol with a parenthesis right there. Excellent, parenthesis. I think they may have you actually write this in set notation, and that's with this pretty little set of all x such that x is less than 7 halves. Yeah, like that. Good, good, good. So this is solving it. And if you write it in set notation, it looks like that. Here's the graph, and here's interval notation, all meaning the exact same thing. Great, let's try number 2. 2x minus 5 greater than 6x minus 17. Let's get all the x's over here, so we get minus 6x, so we get -4x, minus 5 greater than -17. Add 5 to both sides, and we get -4x greater than -12. And so we now divide by a -4. And what happens when we divide by a -4? This guy switches direction. So it is x not greater than, but less than. -12 divided by -4 is a 3. So let's highlight that. That was important. This negative sign means that that guy had to turn around the other way. And that was important to pay attention to. Okay, so x less than 3 is the answer. So let's write the interval notation here. There's 0. There's our important number 3. And we are getting less than 3. So that will be like an open circle or a parenthesis right there. And all the way down because x is smaller than. Interval notation, what does that look like? That says, well, we're going the interval that goes all the way down from -infinity up to 3. So we'd write -infinity up to positive 3. And that same parenthesis right there on the end. All right, I want to do this one in just one more way so you can kind of see why this switching of direction is so important. If we were to have subtracted 2x from both sides, we would have ended up like this, 4x minus 17. Add 17 to both sides, and we would have gotten 12 is greater than 4x. Now we would divide by a positive 4 and get 3 is greater than x. This is the same statement as that right there. And so notice if we would not have divided by a negative, we certainly would not have gotten the exact same answer. So this x is smaller than 3 is the same exact thing down here. Good. Alrighty, let's try another one. Number 3. Okay, we're going to solve this the same way. We have parentheses, so we got to get rid of them by multiplying those through. Negative 3x minus 15 less than or equal to 17 plus x. Subtract x over here, and we get x negative 4x minus 15 is less than or equal to 17. And add 15 over there, we get negative 4x is less than or equal to 32. Divide by a negative 4 and we get x is greater than or equal to a negative 8. Let's see what that looks like on the graph. There's the number line, here's our 0, here's a negative 8 right down there somewhere. And it says that x is bigger than or equal to. So that would be a solid dot or we'll put a solid dot there, or a bracket, and it goes this way. There we go. And so it goes from negative 8 all the way up to positive infinity. Can't hit that one, but we do hit that one, and that's the symbol for it. So that's interval notation. I guess I should, just to make them look pretty, this is set notation there, and this would be set notation there. So if it says put it in set notation, it'll have these brackets, these braces, which aren't really that important to the substance of the answer, but are proper notation. All right, so then we have, let's try the next one, number 4. We have fractions and parentheses. And in which order do we go? We get rid of the parentheses first, so let's jump that in. So 3/5 x minus 6/5 plus 7 greater than or equal to 5 minus 7/2 x. Good. Now we got to get rid of these fractions. How do we get rid of fractions again? We multiply by that least common denominator. Magic wand right here. Times by 10, times by 10, times by 10, times by 10, times by 10. And let's see what happens. We times this. 10 times 3/5, that cancels, and we get 2 times 3 is 6x minus, that cancels, get a 2. 2 times 6 is 12, plus 10 times 7 is 70, greater than or equal to 50, minus, and then this one leaves a 5, and you get 35x. And if you need to multiply those in your calculator, no worries, just go ahead and do that. 10 times 3/5 will be 6. Okay, let's collect all of them together, all the x's together. Add 35x to both sides, and we get 41x plus 58 greater than or equal to 50. And then subtract 58, we get 41x greater than or equal to negative 8. Divide by 41, we get x is greater than or equal to negative 8 41sts. And so there's 0. Negative 8 41sts is a fraction just on this side. Let's zoom in so we get it far enough away from 0. Negative 8 41sts, like that. Good. And we are going greater than or equal to. So we're on this side with a solid dot, which is symbolized by this bracket symbol. So the interval notation would be negative 8 41sts up to infinity, and we can't ever hit infinity. Now, before we leave, we should note that if you would have gotten the x's over to that side and the numbers over to that side, you would have been down here and divided by a negative 4, which would have switched the sign back to where it needed to go. And similarly here, if we would have taken the 6x over to that side and had a negative 41 and a positive 8 over here, it would have switched, so the x would have remained in the, let's do the good, just like that. Okay, good. Alrighty, good deal. Now let's go on to the next stuff. Now we're going to move on and talk about compound inequalities. Compound inequalities are kind of cool. You can put two things together with an and or an or. So let's write a couple of these up here, like x is bigger than 5 and x is less than 8. Let's see what this does when you put this in here. X is bigger than 5. Okay, so we can graph that puppy. You have 0. Here's 5, and here's 8. Good. And bigger than 5 looks like this. And less than 8 looks like this. And goes on forever down there. Well, now comes the thing you need to focus on and think about. What does that mean, and? It means at the same time. Well, shoot. This is starting to get a little ugly. Let's go backwards just a little bit. Undo those. And illustrate what happens, because you're also going to see some that look like this. X is greater than 5, or X is less than 8. And you're going to be expected with those exact same things to distinguish between how they are compounded and what these and or mean. Let's look at, for just a minute, a small little map of a town. I'm going to do, here's a road that looks like, I don't know, 2nd North. Here's another road, and this looks like 3rd North, something like that. And here's one that comes through 2nd East. Let's label that 2nd. I think colors are best way to explain this. If I look at these two roads and I say, okay, where is 2nd North and 3rd North? Well, geez, they never cross, so there isn't a 2nd North and 3rd North. Now, you could say where's 2nd North and 2nd East, and you're like, hey, there's the intersection right here. So the word and means intersection. And in particular, when something is red and something is blue, when something is red and the other thing it's intersecting with is blue, then red and blue make purple. So let's graph this X is greater than 5 in red. And let's graph the X less than 8 in blue. And now let's do where the purple is. Ta-da! There's the purple right there. And we can write that as a compound inequality. X is less than 8 and bigger than 5 at the exact same time. That's our solution, and we've written those together as a compound inequality. Now, if I were to ask you a different question with the word or, say, hey, would you meet me on either 2nd North or 2nd East? You're like, well, that wasn't very specific. Right, because the places that I have just described are anywhere on either one of them. So I color everything, whether it's on this one or that one. In fact, you could do it with things that are completely disjoint, that never connect. You could say, could you meet me on 2nd North or 3rd North or 2nd East? And, well, nobody would say that because that's so not descriptive, but it would encompass everything. Let's see what that looks like on a number line. So even if we did this 0, 5, 8, same exact setup, let's look and see what or does. Here's the red, and the red goes up clear to infinity. The blue comes right down here. Now notice with the or statement, give me numbers that are either bigger than 5 or greater than 8. That means they're colored either red or blue. We're not just looking for the purple ones, we're looking for anything that's colored, and oh my goodness, every number is. This number fits the criteria because it is less than 8. Numbers up here fit the criteria because they're bigger than 5. So this solution is everything, all real numbers. So when you put these together, some unusual things could happen. You could restrict it tightly, or you could expand it to hit everything. Let's see a couple more examples. All right, here we go. We have X greater than 5 and X less than or equal to -3, and I think this is great. Our end answer is going to be wherever the red and blue connect, because it's red and blue, so we are actually looking for the purple here. So let's do that. X is greater than 5, so we've got open circle or a parenthesis to come up here this direction. And X is less than or equal to -3, so that would be a closed dot or a bracket as a symbol that we actually include that. And where's the purple? There is no purple. This has no solution. Some of you have seen the empty set symbol, and you can put that as well. But there is no solution. There is no number that is bigger than 5 and less than or equal to -3 at the same time. Let's see what an or does to that exact same statement over here. We have x bigger than 5, or x is less than or equal to -3. But we're not looking for purple. We're looking for anything that is colored either red or blue. So let's graph it and see what it looks like. So here's the open circle. Can be represented with a parenthesis. Headed that way. Good. X is less than or equal to -3. So that's a closed dot. And it goes this way. Good deal. And so we want all the numbers that are colored either one of them. So our solution looks like this. This is where set notation is very valuable. X is greater than 5, or x is less than or equal to -3. You just can't simplify it anymore like we did with the and there. These are shooting off and they don't overlap, so there's no way to simplify that even more. I'm going to write this in interval notation. This is from -infinity up to -3, and it has open there because you can't hit that, and closes there, just like that symbol up on the graph. And then this is a union symbol, and it goes from 5 up to infinity. There you have it. And that guy right there is an interval notation representation of this, which is representing that graph right there. Okay, that should help you with compound inequalities. To the boards! And here are some problems for you to do on your own. 2x number 1, 2, 3, and 4. Go ahead and give them a shot. Pause the video and then press play again when you've had a chance to work through them and you need to see the answers. Okay, welcome back. Notice we have a compound equality in each of these. With that, we're going to use a couple of colors. So this one we're going to do in blue, and then this guy we'll do in red. So 2x plus 3 less than 11, subtract 3, and we get 2x is less than 8, x is less than 4. Let's find out what that guy looks like on a graph. Here we have there's 0, and here is 4, and we're going to be, let me see, x is less than 4, so that's this way, going down. Okay, good. And then the red one, let's do that guy. Add 7, we get 4x greater than or equal to -4. Divide by 4, and we get x is greater than or equal to -1. We don't switch directions because we didn't divide by a negative. We divided by 4, so it stays the same direction. So that's -1 is about right here, and it says it's greater than or equal to. So it goes like this. There we go. And we have the and. Now remember, red and blue and red make purple. So we are looking for all the numbers that are then purple. And you see it's these guys right here from -1 up to 4, but 4 is not really blue. That's just the border of it. So that's our purple one right there. And that's where our solution is. So we can graph it like this. And our answer is, notice that it's x is less than 4 and greater than or equal to -1 at the same time. This is an and compound inequality because we just take where they cross. And so this is what the solution looks like when it's made all pretty with the set of all x such that going in there. Good. And interval notation. We are doing the interval from -1 to 4. 4 is open, -1 is closed. There we have it. Good. Number 2. 5x plus 2 is less than -3. We'll make this one blue. Subtract 2 and we get 5x is less than -5. Divide by 5 and we get x is less than -1. Let's put that on the graph and see what we look like right now. There's 0, and so we have -1 is about right there, and it goes that way. So we're like this. Good. And now let's do the other guy. Put him in red. So subtract 7, we get 3x is greater than or equal to 9. Divide by 3 and we get x is greater than or equal to 3. So 3 is about right here, and he goes that way. Now you'll notice that blue and red on number 1 made purple when you did and. Here we want all things that are either red or blue, and that includes all of these guys. So how do you write that? Well, there's only one way to write it, a set of all x such that x is either less than -1 or x is greater than or equal to 3. There's not a shorter way of writing that guy. Interval notation is kind of interesting though, because we've got two separate intervals that we have to account for. So we go from negative infinity to -1, and we don't quite touch -1. And then we have this other one from 3 up to infinity. And we put a U in between them, like that. That's the symbol for union or. We're just sticking these two together. Excellent. Let's move on to number 3. We're back to and, so we're going to do blue and red make purple. Let's do the blue guy first. Divide by 2 and we get x greater than -4. Okay, what does that look like on the number line here? We have that 0, and there is -4 right back there, and it looks kind of like this. There we go. Okay, do the other one. Divide by a -3, and we get x is greater than or equal to -2. Now notice we had to switch the sign because we divided by a -3. So we got -2 right here, and he goes about like this. Now, remember what we started with in the first of the problem, the word and is purple, so red and blue. So name all the points that are both red and purple. And you can see that it's all of these guys up to here, and then it stops. It turns out that the numbers that are bigger than -2 and bigger than 4 at the same time is everything bigger than or equal to -2. These guys were not in both of them, but all of these ones, all of the red, were also colored blue. So that's our answer. So here we go. That is where we'd go -2 up to infinity. And we include -2. There we go. The graph is the purple. And I probably should write this down here like this and make it nice. There we go. All right. Let's try the next one, the last one. 5x less than or equal to 7. So this is x is less than or equal to 7/5. Ooh, got a fraction there. That's not too bad. Let's see what she looks like. There's a 0, and then where's -7/5? Somewhere right down here. -7/5. Oh, +7/5. Oops, let's take that off and go back to +7/5 here. There we go, +7/5, and we're headed down from 7/5. So we're going, all of these numbers are colored blue. Now let's do the red one. -2x plus 9. So subtract 9 and we get -2x less than 6. Divide by a -2 and we get x is greater than -3. Dividing by a negative, we have to switch the sign. So we get -3 is like down here, and we're going greater than. So we don't include it. It's open, like an open circle there. All right. Now, if this were an and problem, our answer would be stuck right in the middle, kind of like this one up here. But it's not. We want everything that is colored either red or blue. And in that case, we have, well, stink. That's everything. Everything is colored either red or blue. Holy cow. Yeah, the solution to this is all real numbers. The interval is from -infinity to infinity. I mean, look at that. All these ones are colored blue. These guys are all colored blue and red, and those guys are all colored red. So the graph is actually both things going both way forever. Tough question there. Good. Now you can get on to your assignment.